In the previous video, we performed sensitivity analysis with respect to the change of the objective function coefficient of a non-basic variable. Here, we are going to look at the analysis with respect to the change of the objective function coefficient of a basic variable. So let's start. Just a quick reminder that what we actually need to do for maximization case is that we need to check whether each variable in row 0 has a non-negative coefficient, and in some cases we are also going to check whether each constraint has a non-negative right-hand side. If that is the case, then the current basis is still optimal. Okay, so the second change is changing the objective function coefficient of a basic variable. We are going to use the example of the Dakota problem again. Now we are going to change the price of x1 from $60 to become 60 plus delta. You may notice that in the original problem, the optimal solution has the variable x1 as the basic variable. So we are here changing the objective function coefficients of a variable that is a basic variable in the original problem. If we look at the formula, changing the price of x1 means that we are going to change c1, the small c1. However, because x1 is a basic variable here, so it means that we are going to change CBV. When we change CBV, it means that it affects all coefficients in row 0, both in the left-hand side and also on the right-hand side, because those formula, they all involve CBV. Okay, so the change of C1 means that CBV changes as well. As a result, the entire row 0 is affected. The current basis S1, X3, and X1 will remain optimal if and only if the entire left-hand side of row 0 is still non-negative. So we need to check whether all coefficients are in the left-hand side of row 0, they are still greater than or equals to 0. From the previous slide, we need to check whether the entire left-hand side of row 0 is still greater than or equals to 0 after the change. It means that we have to check the C hat for all variables. So C hat for x1, C hat for x2, C hat for x3, C hat for s1, C hat for s2, and C hat for s3. However, you should notice that because s1, x3, and x1, they are basic variables in the current optimal basis. So their coefficients are 0, because we are going to check if the change will keep the current basis optimal or not. So for those that are currently in the basis, S1, X3, X1, we just assume that their values are still 0. Okay, because we're going to check whether the change keep the current basis optimal. So we just assume that the current basis is still optimal at this point before the change. So we do not need to compute them and just assume that their values are 0. What we need to compute is that the value of the row 0 coefficients for the non-basic variables, which are C hat 2, C hat S2, and C hat S3. Okay, so remember, even though the change happens in the basic variables, what we need to check actually are the coefficients in the row 0 of the non-basic variables. Okay, so we are going to use this formula, CBV B inverse AJ minus CJ. So this is the CBV, and then CBV is the cost of S1, which is 0 in the original problem, the cost of X3 in the original problem, which is 20, and the cost of X1, which is 60, but now becomes 60 plus delta. So this is our B inverse, nothing changes from the original problem. And then we compute CBV B inverse, and it looks like this. Okay, so now we're ready to compute C2 hat. CBV B inverse times AJ, AJ is A2, so 6 to 1.5 goes here. And then C2 without hat is 30. So this is C2 hat. And then we're going to compute C hat S2 and C hat S3 by looking at the CBVB inverse. So we may use CBVB inverse to say that this is the coefficient of C hat S1, this is C hat S2, and this is C hat S3. So now we have computed all the C hat for all non-basic variables. To ensure that the current base is optimal, we need to make sure that the entire coefficient of row 0 must be greater than or equals to 0. For the basic variable, they are already greater than or equal to 0 because they are 0. So now we need to put the requirements that for C2 hat, it must be greater than or equals to 0. For CS2 hat, must be greater than or equals to 0. Same thing for CS3 hat. And then from here we simplify the inequalities, and then we get these 3 requirements that we need to fulfill. We take the intersections of all the inequalities that we need to satisfy, and then we get that finally the change must be between -4 up to 20, such that the current basis remains optimal. Since the current price for X1 is 60, so because delta can be from -4 to 20, it means we may go down from 64 units, so becomes 56. We may go up 20 units, so it's up to 80. So as long as C1 between 56 and 80, including 56 and 80, it means that our current basis remains optimal. So when the current basis is still optimal, it means that the values of the basic variables S1, X3, and X1, they do not change. However, the Z value change. Okay, because it's logical, right? Because if the price of X1 increases, even though you produce the same amount of X1, your Z value will change. So you may need to recompute the total Z value, even though the value of the variables stay the same. From the previous slide, we've seen that the allowable bounds to keep the current basis optimal is between 56 and 80 for C1. Now, if we set C1 less than 56 or C1 strictly greater than 80, then the current basis is no longer optimal. So the reason is if the price of X1, which is a desk in this example, if the price of the desk falls lower than 56, it means that it is no longer attractive to make a desk. On the other hand, if the price of the desk increases up to more than $80, desk becomes very profitable, such that we would like to make more desks to get more profit. So for example, let's see what happens if C1 equals 100. If the price of C1 increases to 100, it means that the change or delta equals 40, because now at this moment C1 equals 60. Now we compute the C hat for all variables. These are the basic variables, so the C hat for them are 0. Now for the non-basic variables, we have computed the C hat with respect to delta or the change. So these are the equations, and then now we plug in delta equals 40. We get the value that C2 hat equals 55, CS2 hat equals minus 10, and CS3 hat equals 70. So now we have a non-basic variable with a negative coefficient. It means that our current optimal solution is no longer optimal. Now we also compute the right-hand side of our row 0 using the formula CBV B inverse B. The CBV B inverse is this with respect to the change delta, and then we plug in the delta equals 40. So this is the CBV B inverse, this is the small b, the coefficient of the right-hand side of the constraints in the original problem, and then we obtain the new value of the right-hand side of the row 0 is 360. Now we use the old optimal table, and then we plug in all the new values. So the coefficient of x2 becomes 55, the coefficient of s2 becomes minus 10, the coefficient of x3 becomes 70, and the right-hand side becomes 360. Other than that, everything is exactly the same with the old optimal table. And then we perform the simplex algorithm as usual. In the maximization case, the variable with the most negative coefficient becomes the entering variable. You perform ratio test and always pick the smallest. This is the pivot, and then you perform error such that in that position it becomes 1, and the other places it becomes 0 in the same column. Okay, so once you've done that, you check again that there's no longer negative coefficient in row 0, so this is the new optimal solution with respect to C1 equals 100. You can see that because X1 or desk is very profitable, so we increase the production from 2-unit desks up to 4 units. So the change in the price is reflected with the result that we produce more desks. Okay, so that's the change in the coefficient of the objective function of a basic variable. The key is that you need to check all the C hat for all variables, but remember that for those that are currently basic variables, we just assume them to be still 0. What you need to check is the C hat for the non-basic variables. So that's all for this topic, and then we're going to talk about the third change in the next video. See you on the next one, and thank you.